Hey, let's go ahead and talk about angle relationships. Now, they are pairs of angles. There's some sort of relationship between these two angles. Now, some pairs of angles are special because of how they are positioned next to each other. Starting off with adjacent angles, they are two angles that lie in the same plane and have a common vertex and a common side, but no common inside points. So, for instance, let's talk about examples over here. Angle 1 and angle 2 are adjacent angles. So these are considered adjacent angles, and we can take a look at them individually. Angle 1 over here, and here's angle 2. They are adjacent. Oh, my bad. They are adjacent because, number 1, they have a common vertex. And number 2, they have a common side. So this is the side over here, and that's what these two angles share, right? So here's angle 1. And then here is angle 2. You can see that this is the side that they share, and this is the vertex that they also share. So therefore, this is these are two adjacent angles. Over here, this is considered adjacent angles because number 1, here's angle 1, and number 2, here's angle 2. And what do we notice? They share this point, and their common side is this one over here. So if I were you, I would definitely just use your finger and just start tracing along. Where's angle 1? Where's angle 2? And what do they share in common? And that's how you figured, okay, these two angles are adjacent. And then over here, go ahead and get rid of that. Non-examples. These two figures or diagrams or whatever you want to call it, they are not adjacent. Starting with this one over here, we see angle 3, and then we have angle ABC. And what do we notice? Well, angle 3 is inside of angle ABC. And what do they say over here? It says no common inside points, meaning that you can't have an angle inside of an angle. Those are not adjacent. So we can say that this is not it at all. So there you go. Let's go ahead and move on to the next one. What do we have over here? We have this weird looking figure. It looks pretty ugly. Angle 3 is over here. And angle ABC is over here. And automatically, if you trace with your finger, you can see that they don't share a common side. This is not it. That doesn't mean anything. They have to have one. So if I look at angle 3, one of these sides over here, they got to share with angle ABC. And that's how you consider, okay, well, that could possibly be adjacent, but in this case, it's not. So let's go ahead and start moving on. We're going to go ahead and talk about linear pair. So a linear pair is a pair of adjacent angles with opposite rays at our sides. Now remember, what opposite rays are is that when you have let's say you have a vertex and it goes in one direction, and using that same vertex over there, it goes to the other direction. Well, what do we see here? Well, it creates a line, right? So linear pair, or liner pair if you want to call it that way, helps us figure out some things over here. For instance, angle 1 and angle 2. So I have an angle over here and another angle here, and you can see that they share this side over here, which are opposite rays. So this checks out. That's a linear pair. A non-example is angle ADB. Here's angle A to D to B, and here's angle ADC. And yeah, they share a common side, but this is not opposite rays. These are not opposite rays. So you're like, okay, that's not it. Maybe that's adjacent angles, but it's not. It does not fit the description of a linear pair. Vertical angles. This is my favorite. Vertical angles are two non-adjacent angles formed by two intersecting lines. Now, let's go ahead and define what intersecting line means again. Intersecting line is when you have these two lines and they meet at a certain point. They meet over here. This is the point that they share. Now, with these intersecting lines, they create vertical angles. And how I remember vertical angles, pretty much simple. Whatever angles they touch or kiss, because they're having a little angle relationship over here, those are congruent. So, for instance, this angle right here this particular angle and this particular angle, these are congruent. So whatever across from each other, they are congruent. Now this angle over here and this angle over here, they are congruent. Okay? So just think of, across of these, when you create these two vertical, or when you create these two intersecting lines forming vertical angles, across from each other, they are congruent. So this and this, they're congruent, and this over here, or these two over here, are congruent. Okay, so if you're stuck, here's examples: angle 1 and 2. So here's angle 1, and here's angle 2. Right? This means that angle 1 and angle 2 are congruent, and over here, angle 3 and angle 4 are congruent. They're kissing each other, and they are congruent. Alright, let's go ahead and look at this non-examples. The non-example over here is saying angle AEB, and angle DEC. This is not an example because, first of all, notice that over here, this looks like a beautiful looking X, right? Over here, this doesn't look like a beautiful looking X, and that's why you can't consider that's these two are vertical angles. You just you have to have a beautiful looking X. So let's write that down. Vertical angles have beautiful looking X. There you go. Next, lines, segments, or rays that form right angles are perpendicular. You have heard of perpendicular before. It's when we have a line that looks like this, and it's perpendicular to a line like that. Maybe you have something like this, and that's perpendicular, right? And what happens when you have a perpendicular line, when you have two lines that are they're perpendicular, they create a 90 degree angle. And then this square represents that 90 degree angle over there, and it creates right angles. So let's go ahead and take a look at number 1. It says name two obtuse vertical angles. Okay, obtuse means your angle is 90 degree or above 90 degrees, but less than 180. So taking a look at this figure, can I find vertical angles that, number 1, it has to look like an X, and 2, the angles have to be greater than 90, less than 180. I look at this one over here. We see that this is a beautiful looking X. This looks like above 90. So we can go ahead and name these two. So we're going to say angle G to C to B. Angle G, C, and B, and angle F to C to D. F, C, D. Now notice that C is the C is in the middle when you're writing these two names, because that is the vertex, right? The vertex has to be in the middle. The common point that they share, they have to be in the middle. So you can see that right there. The common point with these two intersecting lines, that's going to create this, the vertex, or the common side they share. Or sorry, not common side, common point. Okay. Name a linear pair with vertex B. So let's go ahead and look at the diagram. Where the heck is B? Well, B is right here. And we know that linear pair, line or pair, we got to go find a line. Okay, so these are two angles that help us create opposite rays. Here's the line containing point B, and if I take a look, if I highlight or point towards that line over here, you can see that I got an angle over here and an angle over here. So, oh, my bad. So we can go ahead and name these two pairs. So we have, well, the vertex again is B, so that means that when we're writing this, B has to be in the middle. So we can say angle G to B to C, G, B, C, and what's the other angle? B has to be in the middle, so we can say angle A to B to C. And there you go. That's how you name them. Name an adjacent name an angle adjacent to angle GCF. So where is GCF? The greatest common factor. angle GCF. Got to find the adjacent angle. And remember, adjacent means they have to have the same vertex and same side. Okay, so I take a look. Okay, so we can say that here's a side over here, and here's a side over here. Or not, no, I'm sorry. Here's a side over here, and here's the point that they share. So we can say that, man, what about this? Can we say that angle BCG be one of them? Because, yeah, they share the same side, and they share the same point. And if you look at this, maybe, let's see, GCF. What about this one? Angle DCF. Could that be one of them? Maybe. Yeah, I think so. Unless I'm mistaken. But yeah, it looks like they share the same common vertex and they share the same common side over here. If you take a look. You can also write that down if you want to. It says name an angle, so I'm only naming one. Okay. Next one. Name a segment perpendicular to segment AE. So, it has to look something like this, right? So here's my line, and it's perpendicular to that line over here. So segment AE is right here. So what is the line? What is the straight line that is perpendicular to this line over here? Well, what about segment GD? That looks like the answer. So I'll write segment GD. Okay? So really, it's all of you knowing your definitions in order to succeed with these problems over here. Let's go ahead and do take a look at complementary angles and supplementary angles. Complementary angles are two angles with measures that have a sum of 90 degrees. So you have measure angle 1 plus the measure angle 2, which will give you the sum of 90 degrees. So take a look. We say that these two angles are complementary because angle 1 and then angle 2 will give me this whole 90 degrees angle, 90 degree right there. So let's say that measure angle 1 is 65 and angle 2 is 25. If you add these up together, you will get 90 degrees. You will get 90 degrees. Supplementary angles are two angles with measures that have a sum of 180, and it's just the same thing over here, except this one is with 180. You have the measure angle 1 plus the measure angle 2. That's going to give you 180 degrees. So take a look at this particular thing over here. We can see that angle 3 plus angle 4 will give me this line right here, and a line is 180 degrees. Always, always, always. Now, if you don't know, let me just go ahead and tell you. Well, you know what a 90 degree angle looks like. It looks like this, a straight right angle. Now, if I add another right angle just like that, what's going to happen? Well, it's going to form opposite rays. They're going to form a line right here, which, 90 plus 90 was just what? 180. So that's going to help you remember, or maybe if you want to look into, think deeper, that's what it means to be supplementary, right? So, yeah, you can see from here, if you have these two angles, it creates a line, which will give you 180 degrees. Okay, so let's go ahead and take a look at these again. Vertical angles are congruent. We've already talked about the angles that are kissing each other are congruent. And then the linear pair are supplementary because they're 180 degrees, and 180 degrees just form a line. Number 5, it says find the measure of two supplementary angles if the difference in the measure of the two angles is 18. Okay, so when we're dealing with supplementary angles, number 1, let's go ahead and highlight that. That means that I have to equal that to 180s. Now, we're dealing with two angles here, right? One of the two angles, let's call that the first angle, by the way, says the difference is 18, which means I will write x minus 18 because I'm talking about difference, and that means subtraction in mathematics. Now the second angle is something that I don't even know, right? We know what the first angle is, but we don't know what the second angle is. And if we don't know what something is, that is the unknown. And if we call something the unknown in mathematics, how do we describe that? How do we write something that's unknown? Well, we just call it x, right? Because that's what we know in algebra. Unknown means x, and that's something that we have to solve for, okay? Now, I already have my setup here. I have the first angle plus the second angle. And if these two angles are supplementary, that means I have to equal that to 180. So I can just go ahead and start filling in. I know the first angle, x minus 18. I don't know what x is, and I don't even know what the second angle. So the second angle, by the way, if you don't know, the second angle minus the 18 will give you the first angle. So that's going to be x minus 18 plus x, which is equal to 180. And it looks like all I have to do is combine the like terms. So x plus x, that's going to give you 2x, then the minus 18, which is equal to 180. And then I can go ahead and add 18 on both sides because I want to get 2x by itself. So I'm left with what? 2x is equal to 196. And 2x is equal to 196 will give me, wait, that's not 196, that's 198, my bad. That's going to give me x equals 99, right? So I know what the second angle is, right? If this is x and x is equal to 99, that's going to be 99, right? Now, if this is 99 and I'm looking for x minus 18, well, what is that going to give me? So let's go ahead and replace that x with this 99. 99 minus 18, which is going to give me, let's see, 81, right? So my first angle, hold on, let's see. Let's do that. No, let's see. So my first angle is 81 degrees, and my second angle is 99 degrees. If I add these together, that's going to give me 180, and it'll form that line over there. Okay? So you can go ahead and check that way to see if your setup is correct. Number 6 is... Okay, the next problem, number 6, it says find the measure of two complementary angles if the measure of the larger angle is 12 more than twice the measure of the smaller angle. So let's go ahead and find some keywords here. Complementary angle, that means I have two angles that add up to 90 degrees. And we can take a look at the two information here. We have the larger angle and the smaller angle. Notice that the larger angle has more information than the smaller angle, which is great because the smaller angle is really, really easy. It says, find the measure of the smaller angle. Do we actually have any information about the smaller angle? Well, no, we don't. We don't know some specifics on the larger angle has. So if we don't know something, that means that represents the unknown. So let's call the smaller angle. The smaller angle will be x, and then we have the larger angle, which says it is 12 more than twice the measure of the smaller angle. So I know that when it says 12 more, it means I have 12 and then plus, right? That makes sense because if you have more than something, you're going to be including a plus sign, the operation of the addition. So 12 more than twice, which means 2 times something, right? 12 plus 2 times the measure of the smaller angle, which is x, right? Because we said the measure of the smaller angle is x, the unknown. So it's 12 plus 2x. Great. Now, there we go. There we have it. We can go ahead and start setting this up because, again, the definition of complementary is I have one angle plus another angle is equal to 90. So smaller angle plus the larger angle is equal to 90 degrees. Smaller angle, I don't know what that is, but we define that as x. And then the larger angle from the problem, it's 12 plus 2 times the measure of the smaller angle, which we represent as x as well, or just x. Okay, so that's going to equal to 90. Let's go ahead and start combining like terms. I have 3x plus 12, which is equal to 90. Subtract both sides by 12. I should get, what do I get? I think I get 3x is equal to, I believe, 78. Let me see. I'm checking my key right now. Where is it? Yeah, 3x is equal to 78. And then x is equal to, if I divide both sides by 3, I should get 26. Okay, so that's what x is equal to. So the smaller angle, since it's represented as x, I mean, we already saw for x, that's going to be 26. So the smaller angle is going to be 26. And the larger angle in this case, all I got to do is just plug it in. So I have 12 plus 2 times 26. That is going to give me 64 if I put that in my calculator. And then you can go ahead and check these two and see if they are complementary by just adding these two. And if it equals to 90 degrees, you got it. Those are the answers. All right. Number 7, find the value of each variable. So what variables do we have here? We have x and y, and we see that we have two lines that are intersecting they at a point over here. It looks like an x, so that means we're dealing with vertical angles. So what do I say? I say that this angle and this one, remember they're kissing each other, right? It's going to so these are congruent or equal to each other. So I can do 3x plus 50, which is equal to 6x minus 40. And then I can go ahead and start solving. So I add 40 on both sides. I have 3x plus 90 is equal to 6x. Subtract both sides by 3x. I get 90 equals 3x. If I divide both sides by 3, I get x is equal to 30, right? So x is equal to 30. Now I can go ahead and figure out what y is equal to. So notice that we have these two angles here, this angle and this angle, right? If you see those two angles and it creates opposite rays, we can say that those form a linear pair. So this plus this will set that equal to 180. So I have 3x plus 50, then plus y is equal to 180. Now this is kind of weird because you have 3x plus y and we don't know things, but we actually do because we already solved for x, which is 30, right? So all I gotta do is just replace this x with 30. So I have 3 times 30 plus 50 plus y, which is equal to 180. So I will get this. And then going ahead, keep on combining the like terms, I will get, let's see, what do I get? I will get, I'm going to move it over here. I will get, if I subtract both sides by 140, I will get y equals 40. And that's my answer. And we already solved for x and y, so that's great. Okay. The next thing that I want to do is I want to do number 8. It says find x and y so that line PR and SQ are perpendicular. Okay, so where's PR? PR is right here. And then line SQ is right here, and they form perpendicular lines, it looks like. That means that this angle and this angle are congruent. Okay. Let's go ahead and draw those in there. So this right here, they form a 90-degree angle. And also this right here form a 90-degree angle because they make a nice looking cross or an X right there. So, and since they are perpendicular, they create 90-degree angles. Okay, so let's go ahead and find X and Y. So I see 4Y over here. Right, and notice that this 4y is this 90 degrees. We can set them. We can actually set them equal to each other, right? So I will do 4y minus 2, which is equal to 90, and then we're going to go ahead and add both sides by 2. So y is equal to 23. So we already figured out what y is, and now we need to go ahead and figure out what x is. Okay, so now take a look over here. Notice that this angle contains my x's, and it's all associated to this 90 degree angle. And remember, when we have an angle plus an angle, that's going to give me my 90 degrees. Those are what we call complementary angles, right? So all I got to do is I take this 2x and add that to 5x plus 6, and then set them both equal to 90 degrees, just like this. right? Combine the like terms, and I get 7x is equal to 84. And if I divide both sides by 7, I get x is equal to 12. Oops. X is equal to 12. And that's my answer. We already figured out what y is, and we already figured out what x is. So there you go. All right, find. So the measures of two complementary angles are 10x minus 5 and 5x plus 1. Find the measure of the angles. Okay, so we have two angles. Here's angle 1 and here's angle 2. And I take this, I set that equal to 90, right? Or I look at this and I set that equal to 90 because that's the definition of complementary, where you have two angles that are equal to 90. So this is angle 1 and angle 2. So 10x minus 5 plus 5x plus 20. Set that equal to 90 degrees. This is really, really basic. So I have 15x plus 15, which is equal to 90. Therefore, I get 15x equals 75, right? Therefore, x is equal to 5, and that's what x is equal to. But it says find the measure of the angles. I'm not necessarily looking for x. I'm looking for what this angle is, what the first angle is, and what the second angle is. So let's find the first angle. We have 10x minus 5. And I will just replace that x with that 5 that we already found before. So I have what? I have 45 degrees, right? 10 times 5, that's 50, minus 5, that's 45. Great, so that's the measure of the first angle. The second angle is 5x plus 20. Replace the x with 5 that we found. The x is equal to 5. So you're left with 45 degrees, right? And this makes sense because 45 plus 45 is what? 90 degrees. Okay. Second one, or the last problem, is now make the angles in problem 9 a linear pair. That means we got to set this equal to 180. This is just another way of saying complementary. So let's go ahead and do it. 10x plus 5 plus 5x plus 20 is equal to 180 degrees. Combine the like terms, you should get 15x plus, oh, I made a mistake somewhere. Oh, that should be a minus 5. Minus 5. There you go. So you should have 15x plus 15, which is equal to 180. Subtract both sides by 15. I will get 15x equals 165. Divide both sides by 15. I will get x is equal to 11. There you go. Again, I'm not looking for x, but x will be helpful to plug into my first and second. So the first angle, that's going to be 10x minus 5. Replace that x with 11, so you get 10 times 11 minus 15, which will give you 105 degrees. And then the second, that is going to be 5x plus 20. Then you're going to replace this x with 11. So you have 5 times 11 plus 20, which is equal to 75 degrees. And there you go. If you add these two together, you should get 180 degrees, and that checks out.